This is a quick video about connecting visual models and the distributive property to partial products of the standard algorithm. What it really means for us is we are reviewing the area model. So, for example, if I have 21 times 5, I'm going to start by drawing my area model. Okay? I am going to split it into two sections because I have two numbers. I have 20 and 1, and I'm going to multiply that by 5. And then from here, I multiply diagonally. 5 times 20 is 100. 5 times 1 is 5. My solution is 105. And I can check my work afterwards on the side using the standard algorithm. We're going to have 21 times 5. We have 5 1s times 1 1, which is 5. And 5 1s times 2 10s, which is 10 10s, or 100 and 0 10s, which is 105. Same idea. Next, we have 23 times 31. The way that I would do this is I would draw a little bit bigger, and I would do a horizontal line and a vertical line. And I would break it down in this way, where you have 20 and 3, because I have 2 10s and 3 1s, times 30, which is my 3 10s, and 1 1. And then from here, I'd go 30 times 20, which is 600. Then I would do 30 times 3, which is 90. 1 times 20, which is 20. And 3 times 1, which is 3. And then add it all together. So we have 600 plus 90 plus 20 plus 3. Break it down a little bit more. 690 plus 23 equals 713. And we can check that using the standard algorithm. I'm going to put that to the side so we have a little bit more space. Standard algorithm, 23 times 31. We have 1 times 3 1s, which is 3. 1 1 times 2 10s, which is 2. Okay. I'm going to cross that out because it helps me, and I'm going to put a 0 here. The reason being, when I multiply 10s, 3 10s, times 3 1s, anytime I multiply 10s and 1s, it's going to be 10s. So 3 10s times 3 1s is 9 10s. 3 10s times 2 10s, remembering that 10s times 10s is 600s. Excuse me, 10s times 10s is hundreds. Okay, add them together. 3. 2 10s plus 9 10s is 11 10s, or 110 and 100. 100 plus 600 is 700, and I get 713. Now, if you're convinced that you know this way, there's another way that you can do it. I prefer that you don't, but it's possible. And the way that that works is instead of drawing 4 rectangles like you have here, you're doing 2. And what you're doing with that is you're going to break it down a little bit more. And we're going to draw it smaller up top and larger in the bottom so that we can symbolize that we have 3 1s and 20 holes at the bottom. It is flipped from here, but you can flip it whichever way is easier for you. And then we're just going to write 31 at the top. Okay, that's assuming that you multiply 3 times 31 in your head, which is 93, and 20 times 31, which is 620, and then add them together. 620 plus 93 is 713 again. Personally, I prefer to do it this way. I think this is much easier. If you can do it this way without making mistakes, the choice is yours. 343 times 21. Again, personally, I would do it this way, splitting it into 3 sections vertically and 2 horizontally. 300 4 tens, which is 40, 3 ones, times 2 tens and 1 1. Okay, so we end up with 6,000, almost ran out of space, 860, okay, 340, and 3. Then you add everything together, and you get 7,203. And we can check that using the traditional algorithm. Okay, so 343 times 21, which, solving it again, gets you 7,203. The other way that you can look at it, remember, I prefer that you don't do it, but it's possible, is to do it with your extended rectangle, where we will have 1 and 20, because we have 21, and 343. 343 times 1 is 343. 343 times 20 is 6,860. Then we add it together, and you have 6,860 plus 343. We end up with 7,203. Try on your own. 231 times 32. Pause it, check it, and then come back. When I do it, I ended up with 7,392, and I did it my way, where I have 3 columns and 2 rows. That's how I think it's easiest. If you did it differently and you still got to the same solution here, feel free to do it your way, unless the problem specifically asks for area model. Sometimes it will ask specifically for the algorithm, so be careful to pay attention to the instructions.